Well, so this one's got a bunch of fractions in it. You guys remember from yesterday how we handled those, maybe? This one, though, okay. So the yesterday, remember this one? We got rid of all these denominators by multiplying everything by what? Right? Well, why 12? That they all go into, right? Which, like, if you were going to get a common denominator, actually, you would get 12, right? They all go into 12. If I multiply, see, they all go away, right? And kind of the same here, right? 3 and 15 both go into 15, so we multiply by 15. Yep. Okay. But with this one here, I'm not sure if we need to do that, multiply all the way through. Does anybody see where, as we go along, something in there with a couple of fractions may disappear? What do you see? So the first thing you would do would be distribute, right? Think about what you get there when you distribute and what it would do, huh? You'd have negative 2/3 x here, right? Negative 2/3 x. And then what would cancel? When you go to combine like terms, right? Wouldn't you have negative 2/3 x plus 2/3 x? And it goes to 0, right? Follow me? So we don't really need to do that trick here. Okay? If we did, we'd have to multiply everything by what? So that's here. So whatever you miss, just it's in the video or something. Okay? If we were going to do that, what would we multiply by to get rid of those? Something that they would both go into. Give me a number that 3 and 4 both fit into nice and evenly. They both go into 12, right? So if we multiply everything by 12, they go away. But why don't you guys do this without doing that? Distribute, right? And see if one of those fractions goes away. So I'm going to do that right now. Yep, right there. Okay? Let's see, it looks like most of you got this part, negative 2/3 x minus what, guys? 12 divided by 3 is times 2 is 8, right? Remember on a fraction, guys, the top number means to multiply and the bottom number just means divide, right? It's that simple. Is x like that, right? If you guys are waiting for me to do it and just copy it down, then you really should raise your hand and ask, how to do it for that, right?
I think I just got negative. I got like negative 2.
For an answer?
So you multiply by 2 and divide it by 3 and then add it together?
You mean when I times the 12, you mean? You could do that, so what's 12 times 2?
24.
Divided by 3.
8.
8. Or what's 12 divided by 3?
4.
Times 2. But it's negative, correct? Yeah. You see when we go to combine these like terms here, they go away, and what are we left with? Negative 8. Right? They're gone. Go ahead. Equals negative 5. 4. Yeah. This is see the X, they made it go on the right hand side there. I'm not going to bother switching. You know about it, man?
Subtract the 2 from both sides.
Subtract the 2, because now we're just going to leave the X over here. So we'll get this out of here. What do you get here? What's negative 8 minus 2? Equals negative 5/4 x. Okay. I want to get the x by itself. Tell me what I'm going to multiply by. You got it? Almost. Almost.
Negative.
Negative, right? Because we want to cancel negative as well. If we get that, multiply both sides now by the reciprocal. So negative 4/5 times this side, and negative 4/5 times this side. Okay, let's do the negative 4/5. First of all, it's going to be positive, right? 10 divided by 5, everybody. Times 4. Huh? 8. Are you the only one that knows that? Okay. I hope not.
Wait, what?
What's 10 divided by 5? Times 4. Positive, right? 8 equals x. All right, get the idea on that one? Hey, look at number 5. All this stuff we're doing with fractions, right? But look at the answer choices they give you.
It's just repeating.
Yeah, but it's in decimals, right? And by the way, I hate that stupid repeated sign. It's so infantile. It's like the line down the equal sign.
What is it?
This means 66666.
Oh. That's what I should have done on the home.
I don't repeat it. It's just, oh, okay. Trying to keep my cool here. But anyway, and this is a Regents question. Just round the frickin' thing to where you need to round it to when you need to use it. Anyway, so what I'm getting at is I generally like to have you keep things in terms of the lowest terms fraction, but part of this problem is in decimal, and all the answer choices are in decimal, right? So now, I would say would be an all right time to, you know, if you wanted to convert these guys to a decimal with your calculator and work with it that way, right? You see why? Okay? So if you have a calculator, go and, I mean, maybe you can do that one in your head. Both of them, right? Go ahead and do that now. If you'd like to convert it to decimal now, do so and just rewrite it. What would 3/5 be as a decimal, guys? Think of it this way. What if I doubled them both? Would it be 6 out of 10? And decimals are tenths. No, not 60. 60%, right? But not 60. Wouldn't it be 0.6? You put 3 divided by 5 on your calculator. You get 0.6. Yeah. 0.6 times x plus, let's see, 4/3. That would be 1 1/3, wouldn't it? What's 1/3 as a decimal? What's 1/3 as a decimal? This should be like you should know one. You should know half as a decimal, 1/3 as a decimal, 2/3 as a decimal, like that.
Oh.
You should know.
60.
No.
0.6.
0.66667. Some point you round it to a 7. So this is what? 4 divided by 3. 1 1/3. What's 1 and what's a third? So somebody just got up to get a calculator, and I'm asking a question about what you're calculating. You're staring at me. Put that in your calculator. Put 4 divided by 3. 4, hit the divided by button, 3, then enter. Yes, repeating, right? I'm not going to use the repeating sign. I'm just going to leave some 3s until I feel satisfied. Huh? No, it wouldn't round up to 4. 3, it's just 3, 3, 3, 3, right? And the next one would be a 3, which is less than 5. So I'll keep this one as a 3. What? You know the rule.
No, like not like now, but like in the. Go to the nurse.
In like what? A minute? An hour?
I just didn't.
Would you like to go to the nurse? Okay, why don't you go to the nurse? Okay? Yeah, there we go. Feel better. Okay. Can you guys take it from here? Probably, yeah. And then these guys cancel, right? And if you divide by 0.6, tell me what you're left with over here. You see what I crossed out? Did you see what I didn't cross out? All right, so what am I left with? Yeah, equals, did you push buttons for that one? Where's the calculator? Oh, you're injured, I'll get you. Tell us what you get. One 1.7333, whatever, right?
All juniors and seniors to the auditorium, please.
Okay. I'm sticking with you now. Go ahead. Here's right. And now tell me what to do next. The what? 0.3, yes, exactly right, from both sides. Probably should, 1, 2, 3, probably should keep it the same amount of decimals. I don't know. Doesn't matter, it really doesn't make too much difference. And so what do you get when you get to that? 0.4. There you go, choice 2. Okay? We understand that one? All right, what part do you miss? Where did I lose you? So is it, in some way then you're saying it's unlike the other problems we've done when we, is it because?
The decimals.
Oh, well, it doesn't, they're just numbers like any other numbers, right? And so it's like, it's fine. But, I mean, it's not, it's kind of like this. Yeah, I am. It's kind of like this, right? I mean, did you understand this one?
Yeah.
Right. This is kind of like the one we just did, but it had decimals here and there. It works the same. They're just numbers like any other numbers, that's all. Does that help you? Okay. But so, in other words, but like mechanically, you get how to do it then. It was just decimals. Okay. There you go. Ask questions if you get lost. So read this one. So, read that. Solve it algebraically for what? Okay. You guys know what they mean by exact value. Tell me what you think you know when they say exact value. Not necessarily a whole number. Okay, so maybe you don't know. All right, let me ask you a question. Put 2/3, so this is just a little aside here. Put 2 divided by 3 in your calculator. What do you get? And it goes on forever, right? 0.6666. Some point you'd have to round it to a 7, right? Because the 6 is greater than 5. Okay, everybody with me? It goes on infinitely, but at some point you have to stop because you don't live forever, right? You're going to keep running. So, is this an exact value right here? What I've written, this decimal. Is that exactly what 2/3 is? Why not? Is what? Okay. Well, okay. What if I go out more decimals? Will it be exact then? What if I go out another 100 sixes out that way? Well, then will it be exact? Like go 100 more? I'm not. Don't be exact. We'll just leave that in kindergarten where it belongs. Okay? No, because it goes out infinitely. Even if I go out another million places, it's still not exact, right? It's probably as exact as we need it for most applications, right? But this is an estimation because at some point you have to round it, right? This form of the number is exact. This, as you write it as 2 over 3, that contains every infinite decimal 6. As you see it like this. Does that make sense? It's a little abstract way to think, right? And the same with, say, like 1/3. Right? 0.3333, and on and on and on, right? Which of these is exact? The 1/3 or the 0.333? The 1/3. Why is the 0.333 not exact? Because I had to round it at some point to some final 3, right? But we know there's more, no matter how far. You get the idea? Okay, so when they say exact answer, they're meaning no decimal. Unless it happens to be a repeat like 0.5 or something. Sometimes you'll see that, right? But generally they mean a fraction, okay? Does that make sense? So this is just a little, I want to erase it, a little bit of an aside here. All right, so that being said, why don't we go through and do this one? Well, we got x's on both sides, so yeah, we are going to have to distribute, right? Because we'll have to like unlock this x out of here, right? So everybody do that, right? Go ahead and distribute. Try to get all the x's on one side and maybe find a way to get rid of that fraction, okay? Everything by 3/2, then I'll have other fractions in play, right? So what could I multiply it by? This entire equation? What? You mean 3? Yeah. Multiply every term in there by 3. And guys, by the way, to be clear, these things in here are not a separate term, okay? This is a term. When I say multiply every term, that's a term. This whole thing is a term, right? That's a term. Does that make sense? So you don't have to, you're not going to multiply the 3 inside the parentheses, right? It just times this whole thing, which cancels that 3. You got me? Okay. And when we do that, what do we get? 18. Keep going. That one and then this one. What's 2/3 times 3? 2/3 times 3. Just 2. It's, okay. It's 3 divided by 3 times 2. In other words, the 3's cancel. That's the whole reason you did it, isn't it? That's kind of funny, because the whole reason we multiply by 3 is the part you're not telling me. Okay. Times x plus 5, right? Equals what? No. Not 12. X. Mathematics is a language of precision, right? And so I will pause every time you're imprecise, so you become precise. Okay. Now you can distribute through, get all the x's on one side, everything else on the other, okay? Don't sit and wait and stare at me. You're doing it, right? We all at least get to this point? Okay. Let's combine like terms over here, shall we? So negative 2x, the negative goes with it, right? What? Plus 8, 18 minus 10, plus 8 equals 12x. Well, my x is on one side. Right, yeah, go ahead and do it that way and get your x on the right, sure. You can, I'm just, yeah, that's fine, but I think you know by now, but you can do it. I'm not saying you don't, right? Do that way. I'm just going to do it this way, because I want them on the left. Just you did it the other way, you won't run into this, but I'm doing it this way. What do I end up with here?
-14.
Negative 14x plus 8 equals what?
Exactly.
Oh, what do I do?
For
There's no
another-
way to represent what's left over there, is there?
Put a 0.
Thank you.
Dang.
I do that because kids, I find it funny that kids don't know what to put when stuff goes away. Huh?
Exactly.
Yeah. So if you did it the other way, you're not, it's going to look a little different, right? So we get negative 14x equals negative 8. What me do now? Divide by what now exactly? Negative 14. Precision, right?
That's for your.
Remember, the way you said it, you were 28 off. Right? Divided by negative 14. So we get x equals lowest terms. It's going to be positive or negative, first of all.
Positive.
Yep. What can you divide both top and bottom by? No, not 4. 4 doesn't go into 14.
2
2. Go ahead. What's 8 divided by 2?
over 7.
4/7. There you have it. Okay. All right, one more. Let's see if we can speed it up a little bit here because I'd like to get through this before I retire 14 years. That'd be nice.
14.
I don't know, some ridiculous amount of time. Well, this one should be pretty simple. That doesn't look too hard, does it?
No.
Are we going to have to distribute here, or can we just divide by negative 2?
You could divide, but.
Well, we got x's both sides, right? So I probably should distribute. If I did divide, then I'd have fractions and stuff too. So, yeah. So go ahead, right? Distribute the negative 2. Get all your x's on one side, right? What do you get when you distribute?
-2.
Negative 2
Plus 4.
plus
8.
8x equals 3x plus 8. All right, take it from there. All right, let's do this. So we add 2 to both sides. Plus 2 there, under the 8 plus 2. All right, so we get 8x equals 3x plus 2. What do you want to do now?
Add the 3.
You mean to do what exactly? Yeah, subtract it from both sides, because it is positive. Right? I'll go up here. We get 5x. Wait a minute.
Over.
Equals 2. Wait, whoa, hold on.
You.
What happened here? What we
You
do?
added the 2 before you put the 3 on the other side.
Oh, 8 plus 2 is 10. That doesn't matter. Somebody said 2, and I wrote 2. Oh my, yeah, oh, they must have. Why would I write 2?
Because you messed up.
Can't, that's just not true.
I trusted you.
Well,
You trusted you to do a lot of things. 10.
divide by 5.
And okay, x equals.
X equals 2. Go to those.